Hello, welcome to session 2 of QuickQnect training. In this session we are going to talk about the job preferences, how to set the preferences for QuickQnect, and also we are going to see how you can export and import connections inside Tekla model. So in the beginning the preferences should be set with the help of a connection design engineer. And usually it is one person in a company who will be responsible of doing this, and the detailers will usually not set the preferences, but it is important to understand what is behind this and how it works. So when you sign into QuickQnect and you are into the QuickQnect dashboard, if you want to start a new job, there is a button here called New Job. Usually I don't use this. If we have a project that has been created previously and we have set the preferences, it is very helpful to use that as a template. So to use this as a template, you click on, let's say, those are the listed jobs. As you can see, 1, 2, 3, 4. To use it, we can click on copy job and we can call it a name, let's say demo-2. for example, and click submit, or 3. So once you click submit, this job is now created. If you click this edit button or even click the job, you can edit this demo job. Now this is the preferences, and as you can see, there is left hand side here where it has different pages or tabs of the preferences. There is basic information, connection types, then the advanced minimum job requirements, connection type, detailing, preferences, and so on. And then there are the optional information. If you look at the basic information, you can type your main information, job name, fabricator, and so on. Then the imperial and metric section, this is where you'll define your building code, the units, for engineering, profile catalogs, and so on. Next is the optimization. There are 3 optimizations available in QuickQnect. I'll explain this, what each one of those does. So preference optimization, this one will run 9 different preferences, and each one of them has different connection types, different bolt sizes, and so on. This is usually done in the beginning of the project as an analysis phase to identify which connections or which preferences will be more cost effective. The second thing here, bolt optimization, this does only bolt optimization, which is trying different spacings and bolt sizes. So it starts from 3 inches, 3.5, 4, up to 6. Of bolt spacing, in order to find to design the connections based on the minimum number of bolts that can it be designed for. So this will reduce the number of bolts. The last one is doubler optimization. This one, if you have a beam with a large cope, let's say a small size connected to a large beam, so you get the cope size is large, a portion of web has been cut. So you need to reinforcing this with a doubler. So what the doubler optimization does is that instead of using doublers, we try to increase that filler beam size. So if it's W8 by 10, we can try W10 by 12, for example, and see if that works. So we're not going to change anything, but we'll provide you with a report that if you use different sizes, you can avoid using doublers. So it's very nice and helpful feature. So once you set the preferences for the first page here, the basic information, you click on submit to save your settings. Then, as you can see here, there are the listed other pages, and also you can go from here. So I'm going to go from the left side up to the bottom, going through each page. Next page is connection type. The connection type where you will set for each framing condition. The first and second, third, and fourth preference. Those are like priority levels. So beam to beam you can choose first priority shear plate, second priority double angles, and so on. So QuickQnect will try the first one. If it doesn't work, we'll try the second, and so on until the fourth. You can set only the first one if you want the design to be only shear blades, for example. But if you want, let's say, to try single angle, then double angles, then you can set the order as you want. You can define if the beams are shear only or shear and axial. So if the beam ends have shear only loads, you can define specific connection types. If shear and axial also, you can switch from this here and choose the connection types. So those are all the framing conditions, and once you set, you click on submit to save the settings. The next is the forces. Okay, you choose the design basis, LRFD, AST, and QuickQnect has different types of options to control the loads. If the loads are not inside the model, for example, if we have here under the UDA the reactions, QuickQnect will design based on those reactions. So that is if the design drawing shows end reactions, but let's say the design drawing is saying that you should design based on a table or a UDL value. So what you can do is that you can go here to the forces, you choose UDL factor, and then you define the UDL value for composite and non-composite. In order for QuickQnect to identify if it's composite or non-composite, you switch the option. I usually prefer insert number of studs. So this one, what you can do is that you go to the Tekla model, under the UDA, under field studs. If this field has a number, let's say 7 or whatever, this means this is a composite beam. If it doesn't have any number, this means it is a non-composite beam. And this is only useful if you have different values of UDL for composite and non-composite. But if they are the same value, it doesn't matter. In UDL also, we use a minimum, or not minimum, we use short span values. Usually the short span in UDL gets high reactions. So to avoid this, it is recommended that you input the reactions for short span, less than 10 feet, between 10 and 15, for different beam sizes. This is how you can avoid having high loads for short span, but of course you need to discuss with your EOR. Another option is that you can design based on a table. So you can choose, let's say, W8 will be designed for 10 kips, and then W12 will be designed for 20, and so on. Or you can even specify specific profile. W12 by 79 will be designed for 30. So that's how you can fill up the table if you need, and then you click on submit once you complete. The other option is do not connect remaining, and there is another option called 90% of factored beam shear yield capacity. Those are also can be used if required. Notice here that there is a minimum number of bolt rows. This is available for all the types. Even if you have a UDL factor, you can still type the minimum number of bolt rows. If that's a requirement by the EOR, you can input that here. Next is the minimum job requirements. This first is exactly the same as forces, the first section, so we can skip this. Then would you like to design moment connections? Would you like to design vertical bracing, axial load information, integrity checks information, then lateral displacement and torsional strengths. Those are mostly engineering related information. and should be filled by the connection design engineer. Then the material grade, what are the angle grades, shear blades, and so on, different types of material, even weld, you define the material grade you want to use. Connection preferences for spandrel beams, if you want the spandrel beam to be full depth shear blade, or if you want to include full depth stiffener, you can check it from here. And remember that in order for QuickQnect to identify the beam as spandrel or not, you go here and check this as spandrel. You need only to do this if you want a spandrel beam to be designed for backup stiffener or full depth shear blade. So you can highlight the spandrel beam like here, and you choose this yes if you want to include special requirements for spandrel, but if not, you don't need to do it in the model or here. Erection safety, this is for OSHA standards. You can drop the anchor or eliminate top and bottom top right bolts. You can do it for beam to column web and beam to beam. This is for in case of the double angles and you have two beams connecting into one web or of beam or column, so you can apply the OSHA safety options if needed. Stabilizer blades options, again mostly engineering related information and needs to be done by the connection design engineer. Then minimum and maximum material thickness, this you can define the minimum and maximum stiffener, shear blade and angle thicknesses if needed. Once you complete, you click on submit and you move to the next tab, which is Fabricators connection type. This is the same as connection types we discussed here, but with different UI. So we can skip this. Then detailing preferences, this is related to detailing. First, the scope clearance, you want standard or non-standard. If you have robotic machines and a specific scope, you can define the scope. Also at different scenarios where you have skewed conditions, you can change different options and preferences based on that. You can define down distance to first hole. Usually it's all self-explanatory. If you read what a section does, you can understand what it means. Then minimum setback at angle, at shear blade and so on. Horizontal distance to first hole. Block and or burn flush, how you want the beam flange to be cut. Wheel tail information, part numbering information, because QuickQnect insert parts like shear blade, angles and so on, you can control how the numbering of those parts looks like. Then you have the preferred angle size for different scenarios and preferred gauge size for different scenarios as well. Then the information about bolt entering and tightening clearance, information about loose parts. Again, most of those are self-explanatory. If you go through, you can understand what it does. This is the Fabricators detailing preferences. The bolt preferences, basically bolt information. So I'm not going to go through again all of them, highlight the important ones. So for example, maximum column flange material thickness that can be bolted, you can select from here. Then you have the bolt selections. So QuickQnect offers 3 types of bolt selections you can choose from. This means that the priority level, so QuickQnect will try the, for here in this example, 3/4 A3 to 5. If it doesn't work, it will try 1 inch A3 to 5. If that doesn't work, it will try 1 inch 1/8 A490. So those are the priority of bolts. and the holes information. You can set the same priority for moment bolts and for vertical bracing bolts. Once you finish, you click on submit, then information for weld, minimum and maximum weld size, and information about the partial joint penetration, complete joint penetration, priority of weld to try, so we try fillet first in moment and then partial joint, and then you can try complete joint. So you can set these options and priorities for welds as you want. There are also, you can define weld axis hole dimensions. Once you complete, you click on submit. Those are the basic weld information. Then the moment options, moment connection options, engineering related information again, material grade, minimum maximum material thickness, clip dimensions, clip type, diagonal or circular, and the dimensions, minimum blade projection length, other information about the moment connections, again mostly self-explanatory, and information related to engineering. Same vertical bracing to column flange. What I need to note here is that QuickQnect design HSS bracing, and the connection type is basically the HSS is welded to gusset, the gusset is welded to the beam and bolted to the column through a shear plate. So this is a connection type that QuickQnect handles, and you can specify the preferences for these connections from here, like the material of gusset and other information, clip size and so on. Similarly, you can define preferences for vertical bracing to column web and so on. Next are the optional preferences. This allows further customization of the connections. So we have defined for shear connection 3 bolt types, for example, and let's say you want to even customize, like have different bolts for shear plates and different bolts for double angles, for example. So this allows you to say, like for shear plate I want to use as a first priority 3/4, and then A3 to 5 bearing. Second priority, instead of 1 I'll use 1/8 A490 and so on. And for double angles I want to use different. So this is mostly for additional customization. It's optional. It is rarely used, but if it is required you can still customize it from here. If you keep it blank like this, it will use the bolt preferences based on the bolt general bolt preferences or the global settings. So you can do this customization for beam to beam, beam to column flange, beam to column web, and beam to embed, beam to HSS, vertical bracing and so on. Next is the optional preferences for custom edge distance. So here for shear plate, for example, you want for 3/4, you can define the edge distance for different hole types like standard, oversized, short slotted, and long slotted. If you keep it blank, it will be based on the code recommendation. Last thing is the iteration control. This is also additional customization regarding iterations. So we have defined the preferred angle size. What QuickQnect will do is that it will try this preferred angle size, but if that doesn't work, QuickQnect will try different angle size. But if you want to try angle size based on a specific order, you can create, let's say, a list here. Let me add this one, then this one, for example. So what it will do, it will try this one. If it doesn't work, it will try this one, and so on. This is for additional customizations of the preferred angle size for double angle connection, single angle as well. Then we have vertical bolt spacing. So connect rise like 3 inch, 3.5, 4, and so on up to 6. But you can still customize it from here what spacings you want to try. So you can include, I want to try 3, 3.5, and 4 only. So those are the only spacings that Connect will use. If you keep it blank, Connect will be using all, starting from 3 up to 6. Then shear plate bolt options and bolt columns iterations. So as you know, we have 3 bolts defined in the general bolt tab. So the first one is 3/4 A3 to 5. So my first preference will be 1 column of bolts. If that 1 column is not enough or didn't work, I will try, let's say, 2 columns of the same 3/4. If the 2 columns didn't work, then I will try 1 column of bolt number 2, which is 1 inch A3 to 5. So you can customize this. Even you can have 3 columns or 4 columns of A3 to 5, or I don't want 3 columns, 2 is the maximum, I want to go to the next size, it's bolt number 2, and so on. So this is how you customize the bolt column iteration and bolt types. You can do this for shear plate. And then we have shear plate thickness iteration. So we define minimum and maximum thickness, so Connect will iterate through this. But if you want specific sizes, you can define and order them with the priorities you want. So that's about the preferences setting. Now we're going to switch to the model, and we are going to run Connect on the model based on the preferences we defined. So to run Connect, you can run it for the full model. You can select the whole model like this, or if you want to run Connect for a specific level, you can open, let's say, level 1, not level 1, maybe this one, and select the members here like this and run Connect for this level. Depends how you manage your project. So in this example, I'm gonna run Connect for the full model. It's a small one, I don't need to split. You go to the Connect ribbon and click on Connect Export. So you sign in like this, and then you choose your company name, you choose your job name, and you enter your session. So I'm gonna call this training session 2 test. So usually the session name should reflect the name. So in this case, I can call it full model or level 1 or level 2, whatever. Or if you have a revision, you call it revision 1, revision 2, and so on. But I'm gonna call it training session 2 test. Select the whole model and click on submit. Okay. Once completed, you can import the session. You will receive an email that this session is completed and you can import it. What I want to highlight is that for a specific project, it depends on the size of the project, the number of beams, and so on. So for a model like this, it's usually a few minutes. The bigger the model, the more time it will take. I have already a session ready, so I can import that using button 2. Oh, it's already completed. So let's import this one. By default, the session will be highlighted, the last one you run. So training session 2 system. Now Connect is inserting the connections inside the model with all geometries, bolts, welds, everything. And the connections also inside Connect will have information about the capacity, connection code, other information. So those also will be transferred to the beams, so that if you want to show in drawings or reports, you can show the capacity of connection, you can show also the connection code that is associated with this connection. The connection code is also will be visible in the reports showing calculations, so if someone is reviewing it, he can refer to it easily. So here are the connections inserted. 174, close. And as you can see, all of those connections are designed based on the preferences we set and inserted inside Connect. So that is the end of this video. In the next session, we are going to talk about the connections in details, what's information inside of it, how to do revisions, how to check the connections that didn't work and try to make it work, and so on. So that's it, and thank you for watching.